In this video, we're going to look at graphs of the form y equals sine x plus or minus b not within the bracket, and y equals cos x plus or minus b. And these graphs shift horizontally, so they move up and down. A graph which consists of a repeated pattern is described as periodic, and all of our trig graphs are periodic functions. So you can see that y equals sine x has a period of 360 degrees because that's when it starts to repeat itself, and the amplitude is 1 because it goes to a maximum of 1 and a minimum of -1. Our y equals cos x curve is a phasic shift of our sine x curve by 90 degrees to the left, and it has a maximum of 1 and a minimum of 1, so its amplitude is also 1, and it repeats every 360 degrees like the sine curve, so its period is 360 degrees. Our tan curve is slightly different. It has asymptotes at 90 degrees and 270 degrees. It doesn't have an amplitude defined because it tends towards positive and negative infinity as it goes towards those asymptotes, and its period is 180 degrees because it repeats every 180 degrees rather than 360. There are two full waves in 360 degrees. So in this example, we're being asked to determine the amplitude and the equation of the graph in the form y equals a sine x plus b, and we can see that it has had horizontal shift upwards from our traditional 0, 0 position. So the amplitude is the difference in the maximum and minimum y coordinates halved. So it's y max minus y min all over 2. So the maximum value from our coordinates we can see is 3, and we're going to subtract the minimum value, which is -1, and we're going to halve this. So it's 4 divided by 2, giving us an amplitude of 2. Be careful when working with negative numbers. So a equals 2 because a corresponds to the amplitude of our curve. Now the next thing we're going to look at is where it's moved to. So if we looked at our y equals 2 sine x curve, you can see I've marked in the key points here and sketched that in. And so it would start at 0, 0, go up to 92, 180, 0, 270, -2, finishing at 360, 0. So for y equals 2 sine x, it would start at 0, 0, and would go to 92. And if we consider where these 2 points have shifted to, so that we've got one to double check, our y equals a sine x plus b curve has gone from 0, 0 to 0, 1, and 92 has gone to 93. So you can see that we've added 1 onto both of our y coordinates, giving us a b value of 1. So the equation of our curve is y equals 2 sine x for our stretch and +1 for our horizontal shift upwards. Now in our next example, we want to determine the amplitude and the equation of the graph in the form y equals a cos x plus b. So again, amplitude is the difference in our y max and y minimum divided by 2. So we're going to write y max minus y min over 2 and replace that with our maximum value, which is 1, and we're going to subtract the minimum value, which is -5, and divide that by 2. So 1 plus 5 gives us 6 divided by 2, so our amplitude is going to give us a value of 3. And this is our a value because our a value corresponds to our amplitude. Now let's consider what our y equals 3 cos x curve would look like. So we're going to need to extend our y-axis so that we can fit in our start point of 0, 3, and then we would have a 90, 0, a 180, -3, a 270, 0, and a 363. So you can see that if we sketch this in, our curve y equals a cos x plus b has shifted horizontally down, and we can consider the key points in order to determine what that shift is. So let's consider our maximum 0, 3 and our minimum value 180, negative 3. So on our y equals a cos x plus b curve, our maximum value is at 0, 1 and our minimum value is at 180, negative 5. So you can see that that shift downwards is minus 2 horizontally. So b equals negative 2, giving us our equation of y equals 3 cos x for our stretch and minus 2 for our horizontal shift down. So in these examples, we want to write down the amplitude and period of each of these functions given the equation of their graphs. So in the first one, we've got y equals 4 sine 5x. So we know that the amplitude corresponds to the value that's the multiplier in front of our trig function. So for y equals 4 sine 5x, a is going to equal 4. And this is our amplitude. And in order to determine the period of a function, we're using the 5 because this is the number of waves that we would have between 0 and 360. And so in order to determine the period of one of those waves, we're going to take 360 and divide that by 5, giving us a period for y equals 4 sine 5x of 72 degrees. So let's consider b. We've got y equals 3 cos 2x. Again, our multiplier is 3, and so this is our amplitude, or our a value, if we were writing this equation as y equals a cos bx. Then we're going to use the multiplier of the x to determine what our period is. Again, we know that the number of waves in 360 degrees is 2, so we've got 360 divided by 2 is 180 degrees. So finally, for our y equals tan 4x curve, our amplitude is undetermined because it tends to positive and negative infinity, which is why there's no coefficient of our tan 4x function. We also need to remember that for a tan function, the number of waves is within 180 degrees because we have 2 repeats in 360. So to determine the period, we're going to take our 180 and divide it by 4, and this gives us a period of 45 degrees for this curve. Now that we've looked at finding the equations and finding the amplitudes and periods of these curves, we're going to look at sketching a curve y equals 4 sine x minus 2 between 0 and 360. And again, that minus 2 means that we've got a horizontal shift, and the 4 means that we've got a stretch. So we're going to multiply our y coordinates by 4, and we're going to subtract 2 from them. The x coordinates are all going to stay the same. So considering our y equals sine x key points, hopefully we know them by now, 0, 0, 91, 180, 0, 270, negative 1, and 360, 0. All of our shifts are happening to our y coordinates for our y equals 4 sine x minus 2. So our x coordinates are going to stay exactly the same. So we've got 0, 90, 180, 270, and 360. Remember, for the x coordinates to be affected, it has to be within a bracket. Now we need to apply BODMAS to our y coordinates by multiplying them by 4 and subtracting 2. So we get 0, negative 2, 92, 180, negative 2, then 270 is going to be negative 1 times 4, take away 2 is negative 6, and 360, negative 2. So you can see by looking at all of these coordinates that where our roots were lying on our x-axis, they're now going to lie on y equals negative 2. So the next thing we're going to do is we're going to split up our x-axis into 90-degree intervals. Remember to use a ruler to make sure they're evenly spaced. We've got 90, 180, 270, and 360. And then we need to label our y-axis We need y equals 2 for our maximum, we need y equals negative 2 for where our roots are shifting, and we need y equals negative 6 for our minimum. And then we need to plot our points. So we've got 0, negative 2, it goes up to 92, back to 180, negative 2, down to 270, negative 6, and finishes at 360, negative 2. And then we're going to join those points with a smooth curve. And finally, we're going to label that curve with y equals 4 sine x minus 2. So our final example, we want to sketch the curve y equals 2 cos x plus 3 in the domain 0 to 360 degrees. So again, we're only affecting our y coordinates, we're multiplying them by 2 and then adding on 3, remember BODMAS. So our key points on a y equals cos x curve are 0, 1, 90, 0, 180, negative 1, another root at 270, 0, and finishing on a maximum of 361. And for this curve, we're sketching y equals 2 cos x plus 3. So again, our y coordinates are going to be affected, our x coordinates are going to stay the same. So we know that our x coordinates are going to stay at 0, 90, 180, and 270, and finally 360, because our shift is horizontal, not vertical. And then we're going to apply BODMAS to our y coordinates to work out their new position. 1 times 2 plus 3 is 5, 0 times 2 plus 3 is 3, negative 1 times 2 plus 3 is 1, 270 times 2 plus 3 is 3, 360 times 2 plus 3 takes us back to 5 again. So we need to mark out our x-axis in 90-degree intervals, evenly spaced with a ruler. So we've got 90, 180, 270, and 360. And then we're going to mark the values that we require on our y-axis, making sure that we are using evenly spaced scales. So we need to go up to a maximum value of 5. We need to mark on 3 and 1 as well, as they are some of our key points. Then finally we plot our coordinates: 0, 5, 93, 181, 273, and 365. And then we join these points with a nice smooth curve that goes through all of these key points, and we label it with y equals 2 cos x plus 3.